All right, now we're looking at the answers to the L'Hopital's rule problems from the book. On number 19, we have the limit as x approaches 0 of sine of 3x over sine of 5x. And remember, the number one rule in finding a limit is plug in. So I plug in 0, which gives me sine of 0. Sine of 0 is 0. Excuse me. Plug in 0 in the bottom, which is also sine of 0, which also gives me 0. So since I have the indeterminate form of 0 over 0, that means I can use L'Hopital's rule. L'Hopital's rule says I take the derivative of the numerator, I take the derivative of the denominator, and then I plug in again. So derivative of sine is cosine, derivative of the inside is 3. So that's why I have 3 cosine 3x. Derivative of sine is cosine, derivative of 5x is 5. Plug in 0 again. So this time I have cosine of 0. Cosine of 0 is equal to 1. So that means 3 times 1 is going to give me 3 in the numerator. And then 0 in the bottom as well. So cosine of 0 is also 1. And 1 times 5 gives me 5. So that means the limit as x approaches 0 of sine of 3x over sine of 5x is equal to 3/5. 27. Plug in. I plug in infinity. That gives me infinity in the numerator. I plug in infinity in the denominator. I also get infinity. So I have the indeterminate form of infinity over infinity. So I do L'Hopital's rule. Derivative of derivative of x cubed is 3x squared. Derivative of e to the x over 2 is 1/2 e to the x over 2. Plug in infinity again. I get infinity in the numerator. I get infinity in the denominator. Infinity over infinity. We're still in indeterminate form, so that means I use L'Hopital's rule again. Derivative of 3x squared is 6x. Derivative of e to the x over 2 is 1/2 e to the x over 2. I've already got a 1/2 there, so 1/2 times 1/2 gives me 1/4. I plug in again. Plug in infinity, still get infinity on the top. Plug in infinity on the bottom, I still get infinity on the bottom. So I do L'Hopital's rule again. Derivative of 6x is 6. Derivative of e to the x over 2 is 1/2 e to the x over 2. 1/4 times 1/2 gives me 1/8. I plug in infinity. Nothing to plug into, so that gives me just 6 on the top. Plug in infinity on the bottom, gives me infinity. So 6 over infinity, same thing as 0. So my answer to this limit problem, the limit as x approaches infinity of x cubed over e to the x over 2 is equal to 0. 31. Limit as x approaches infinity of cosine x over x. In this case, I can plug in infinity. Remember, we said cosine and sine. Anytime I'm doing infinity, gives me some number that's between 1 and -1. So I know the top is just some number that's between 1 and -1. I plug in infinity on the bottom, which gives me infinity. And we know that a number over infinity is equal to 0. So that's how I get 0 there. You can also do L'Hopital's rule as well. Well, nope, I guess you can't. All right, 33. Limit as x approaches infinity of the natural log of x over x squared. Plug in, gives me infinity over infinity. Take the derivative. Derivative of the natural log of x is 1 over x. Derivative of x squared is 2x. This can be rewritten as 1 over 2x squared. Plug in infinity, I get a number over infinity, which is equal to 0. So the limit as x approaches infinity of the natural log of x over x squared is equal to 0. And 35. Limit as x approaches infinity of e to the x over x to the fourth. So I plug in infinity, gives me infinity in the numerator, plug in infinity in the denominator. So I have the indeterminate form of infinity over infinity. Derivative of e to the x is e to the x. Derivative of x to the fourth gives me 4x cubed. Plug in again, infinity over infinity. Take the derivative again. E to the x, derivative of e to the x is e to the x. Derivative of 4x cubed is 12x squared. Plug in, still infinity over infinity. So derivative of e to the x is e to the x. Derivative of 12x squared is 24x. Plug in again, still infinity over infinity. Take the derivative. Derivative of e to the x is e to the x. Derivative of 24x is 24. Plug in infinity. This time we get infinity over a number, and infinity over a number is equal to infinity. So there are your answers to L'Hopital's rule.